Very well. So now let's talk about continuity of some functions and discuss the idea if we can extend the function to be continuous at a given point. Example. Is a function that is defined to us as x squared minus y squared divided by x squared plus y squared. X squared minus y squared over x squared plus y squared. Continuous at the origin. Well, we have some conditions to check, all right? We need to check to see if that given point belongs to the domain of the function. So we need to know what is the domain of this rational function, all right? Recall that the domain of a rational function is the set of all points or their pairs, like x and y, such that with the condition that, hey, I have something on the denominator, my denominator cannot be equal to 0. So the condition is x squared plus y squared cannot be 0. But this is just pure algebra. From algebra, we know that this guy is equivalent to x and y such that the only value that can make x squared plus y squared equal to 0, x equal to 0, and the y equal to 0. So such that x is not 0 and the y is not 0. So what's the meaning of that? It means that my domain is all planes. The notation that we use for plane r to the second r Cartesian product with r minus the origin minus this point 0, 0. Guys, do not write it as just 0. It must be written in origin format. X cannot be 0, y cannot be 0. We are subtracting, eliminating this point from the plane. So if you want to visualize this guy, it is just plane. Hey, this is x and this is y, which is nothing but r squared. And then you are just eliminating 0 and 0 from r squared. So now you have r squared for the plane minus this point, which is the origin, 0, 0. Okay, so this is my domain. The first condition is not met. Well, what's the meaning of that? Since the origin is not in the domain of the function, we're going to say that, hey, it's not continuous at the origin. So this is our conclusion. Since 0 and 0 does not belong to the domain, so we don't have continuity. At where? At the origin.